can we visualize functions of more than one variable? So here I've got the function f of xy is equal to sine of x plus 2 sine y. Well, one way we can do that is to plot it in 3D space, so using z as the output variable. But another very useful way to visualize this is in 2D to plot what's called level curves. So a level curve here, this is going to be a subset of the plane on which f of xy is constant, so it takes a particular value, which in the 3D picture corresponds to taking these cross sections of the graph. So here are some different values of c. And so in the 3D picture you can see it cutting out, this is all of the things that where fxy takes value 1.43, and here's the picture in the plane. So the blue values are for c equals like -3, -2, 1, 0, into some integer values is what it's showing. So let me show a couple more examples like that. So here now we have the function xy, f of xy is xy over x squared plus y squared. So here the level curve at 0 is going to be sort of a boring line, but otherwise we get these hyperbolas. See how it shifts when we pass 0. Then here is a really wild function. So z is e to the negative x cosine y. So here's what that surface looks like. And here's what the different level curves look like. So see how here it's in this row and this row, and then once we cross 0, where it straightens out to these horizontal lines, it flips inwards to now these columns. We sort of have a similar shape, but one is upwards and one is downwards. So the level curves are particularly useful because they lend themselves to a generalization to the next dimension up, which this doesn't quite. So if we now have a function of 3 variables, so let's say x squared plus y squared plus z squared, we don't really have a 4th dimension in which to plot that. But what we can do is look at the level surfaces. So the level surface for a given value of c is going to be the sphere of radius square root c. And so these various level surfaces can give us a way to understand or to visualize the behavior of this function.